What if I told you that our emotions don't work like the way they do in the movie Inside Out by Pixar? There isn't just a tiny little joy or sadness sitting in a neon control room in our brains, pulling levers left and right. Although if they did, I believe joy deserves a bonus and sadness should be able to work from home. Anyways, our brain is a lot more biology-based than our emotions. It's a lot more fast-paced brain alarms, hormonal changes, and a prefrontal cortex that works to calm everybody down, kind of like an overworked guidance counselor. Today, we're going to talk about our emotions and the neural circuitry behind them. When something suddenly matters, the amygdala reacts faster than you do. If a snake wraps around your arm, your amygdala fires before you can even scream. If you walk into a candy shop and see your childhood favorite on the shelf, it activates too. Not because the stimuli is dangerous, but because it's emotionally significant. So whether it's a threat, excitement, or stress, the amygdala's job is the same: to detect, alert, and activate the body to produce a response. The key part of the amygdala that plays a role in our emotions is the central nucleus, or CE for short. This is a part of the amygdala that causes us to react to the stimuli in our environment. For example, seeing the snake on your arm. The CE can cause us to react in 3 different ways. We can react behaviorally, which would send signals to our hypothalamus and brainstem, causing us to freeze, jump, and react. We can react autonomically. Our autonomic nervous system would be triggered, causing us to sweat and our heart rate to increase. And lastly, it can trigger us hormonally, which means that we would release cortisol, adrenaline, or norepinephrine. The main thing here is that the central nucleus doesn't create fear, but it orders the body to go into alert mode. And then our brains interpret our body's reactions as fear, panic, anger, or relief. The central nucleus is important because without it, we wouldn't be able to respond to our environment and especially dangerous situations. When our amygdala is triggered, one way we can react is by exhibiting aggressive behavior. However, exhibiting too much aggression can be a disadvantage. This is where the ventral medial prefrontal cortex comes into play. The VMPFC uses serotonin to inhibit and calm the amygdala. This helps you think before you react. As a result, this decreases aggression and plays a big role in moral decision making. When serotonin is low, our VMPFCs are underactive, causing us to act more impulsively and more aggressively. Emotions aren't just feelings. They're the central nucleus triggering the body's response, the VMPFC regulating that response, and the brain interpreting what those sensations mean. So if your heart races, your palms sweat, or if you cry over a burnt bagel, that's not you being dramatic, but that's your amygdala doing its job and the VMPFC trying to handle all the paperwork.